make it quick, get to the stuff. I'd like to first thank our sponsor, Excella Consulting. And they've given me a couple of slides and a couple of ways of contacting them. Excella.com, @ExcellaCo, and info@excella.com. Just a few points about what Excella is all about. If we can go to the second slide. Excella is very involved in different community groups in this area, if not as participants, oftentimes as organizers and sponsors. And so this just gives you a sense of some of the areas that Excella is involved in. I work for Excella. I've been at Excella a little over 4 years. But what I want to do is give you a sense of what somebody who works at Excella more day-to-day in the development role is like. So if you could come up and just give everybody a sense of what it's like to work at Excella.
Yeah, it's definitely not planned. I didn't even know about this. I found out about this at a user group about 3 years ago, and it seemed that Excella was into software craftsmanship type stuff, so that was kind of interesting, and it's proved true, and I've learned a lot there. We're obviously a software consulting company, a variety of federal and commercial work, which was also appealing to have both. It's a small field of, the company is a very small field, and you kind of get to know most of the people in the company. And we're encouraged to be very interactive and do project-based work, so not like a staffing company, but make suggestions on improving the applications, the overall solution quality. So we are constantly checking in on best practice checklists to make sure that we're following things like unit test coverage and all this, and training new people. If they don't, a lot of people actually don't know how to necessarily do all of those practices to stay in line. So I find myself mentoring a lot in the course of a day, and paying attention to those kind of things that kind of developers like. So it's a good experience for me. If you have any questions about it, I'd be happy to talk about it.
I need more time to eat pizza.
Sorry.
Okay. Next month, January, we have a presentation on the scaled agile framework. So, and the theme of DCAlt.net is to look at different things that either like software engineering type of things like solid foundations, to look at new technologies like Azure, and to look at things that impact the development environment, context in which we work. So there's a lot going on with this idea of scaled agile, and what does it mean to have a program of multiple agile projects. So that's what's coming up in January. I found a speaker for that speaker. In general, if you're a member of the group and you come to these meetings regularly, you want to come and speak, or you know of somebody that you'd like to hear speak, please let me know. That is one of the first ways I figure out who will speak. Some of the things that I do is I look at BostonAlt.net, or I look at New York Alt.net, which is where Steve is from, and I will see who has spoken there, and how I might contact them. So any ideas of where I can steal speakers from, please feel free to give them to me, because I'll go poach them. They're willing to come down here for little money and speak to you on topics they love. So that kind of passion I want to try and encourage. Okay. Without any further ado, I'm going to turn it over to Steve.
Thank you, Steve. So, how's everybody doing tonight? Good? Good. All right. So, tonight's talk is Refactoring to a Solid Foundation. I am Steve Bohlen. I'm currently a Senior Technical Evangelist with Microsoft. And the various ways you can reach me are on that slide. I have a Gmail account for non-Microsoft related communications. I have a blog that I periodically visit and actually might post something to, and I'm also on Twitter at @Bohlen there. Before we get too much, sorry, let me turn the, do you need a mic on this? Is that better?
That's better.
Okay, perfect. So before we get too far into this, it's important to sort of set the stage of sort of who am I, and more importantly, why you should listen to what I have to say here tonight, right? As I mentioned, my name is Steve Bohlen. I read books and write software for a living, which is as opposed to the alternative career of reading software and writing books for a living. There's nothing wrong with the second career. Lots of people have made lots of really good money at it. Lots of people are very good at it, right? My career, however, is very firmly in the first one. I read books and write software. A lot of the software I write is informed by reading a lot of books written by smart people who have the second career. But what you're going to hear me talk about today is real-life software engineering expertise from a number of years working in the trenches. I blog, I record screencasts, I speak at events like this so that I can share what I've learned with others, but also so that I can learn from the people I get to interact with. That's a very important part of why I'm out in the community giving these kinds of talks. It's not just so I can share what I know, but also so that I can learn from those folks in the audience too. So, a little bit about me. I don't expect you to read this slide. It's just here so that if you later on get the deck and you're curious. Some of the high points: I've been developing software for the better part of the last 2 decades in a fairly wide array of languages. Currently, as I mentioned, a senior tech evangelist at Microsoft. I'm one of the co-founders of the New York City Alt.NET group, as Stephen mentioned earlier. I'm also currently one of the co-organizers of the New York City Domain-Driven Design User Group, contributor to a variety of open source software projects, and of course the blog and email and all the rest of that. These logos down the side here, if I were a NASCAR race car, those would be slapped all over me. Just some things that I used to be a Microsoft MVP. When you're hired by Microsoft, you have to drop that, so I'm no longer an MVP, but for a number of years I was, and things as varied as solution architecture, ASP.NET, and Visual C# for a while as well. Important to set the context here. As I mentioned, I am a Microsoft employee, but these thoughts are entirely my own. So what you're about to hear me talk about is not anything official Microsoft canon or otherwise. Bear that in mind. Anybody who's been to any of my talks prior knows that I like a lot of interactivity. If there are questions as we go through the material tonight, feel free to raise your hand, shout out, get my attention, and we'll see if we can engage on getting you the answer. Yes?
I have a question. Can we go back a slide or two to your languages?
Sure.
Which language is that between VB.NET and Ruby? I'm going to learn that somehow.
So that was a short-lived language known colloquially as typo. It was an interesting blending of static and dynamically typed languages, which is why it was called typo. Nice catch, thank you. So, if there are any other questions, feel free to shout them out. Right? I will be doing some heads down coding as part of this, so 2 things about that. First of all, I may not see raised hands, so feel free to yell out. And secondly, if those of you in the far back can't read the code, it's going to be a fairly big point size, but a couple of you in the last 2 rows may have some challenges, so feel free to move forward if you'd like once we start doing the coding. So I can understand where people are coming from in the room here. By a show of hands, how many people have heard of the solid object-oriented design principles? All right. How many people feel they comfortably understand them? Okay, that's better. And more typical, frankly, right? The good news is we're sort of past the point in our industry where that first question elicits just a smattering of hands, right? Most people have heard about this kind of thing, but a lot of people look at it as sort of pie-in-the-sky architecture goodness that I would never really actually be able to do that in my own code, right? So part of what we're going to talk about here today is so that we can deal with those kinds of things. So part of what we're going to be dealing with in today's talk is legacy code, right? Legacy code is one of those wonderful words that means a lot of different things to a lot of different people. Some people think of the word legacy code and say, well, that must be code that's older than 10 years, 15 years, 20 years, right? They attach a chronology to it. Other people look at the word legacy code and say, legacy code could mean code that is old. But what it really means is it's code we're afraid to touch, right? It could be we're afraid to touch it because it is in fact 15 years old and no one is alive anymore who remembers how it works. Or it could be code we wrote just before lunch, but it was so complicated that now that it's after lunch, we can't possibly remember what the hell we had in mind when we wrote it, right? So I like to think of legacy code broadly as that code that we are afraid to interact with, right? There be dragons. Don't go in there. Don't touch that module. Anybody who does, it never works out right. For every bug we fix, 6 more surface, right? all these kinds of problems, right? So that's really legacy code. It's not so much about chronology as it is about safety and comfort you have with working with that code base. And we've probably all, even those of us that might be in startups with a code base that's only 6 months, 18 months old, probably know parts in the code base where we just don't go there. And maybe it works and maybe it doesn't, right? But whether it's even functional or not, we just know we don't go there. Because every time we do, bad things happen. As is the case with lots of legacy code, right? Remember, broadly speaking, code we're afraid to touch. There will be no tests in the code we're going to look at today, right? So, when we have no tests, how do we know our software remains functional? We must run it. Every time we make a change, we must run it. That's how we make sure that software that has no tests works, right? It turns out, in fact, that what that means is that no software has no tests. All software has at least one test. We run it. Right? Our goal should be, of course, to try to get to the point where some level of pre-running it testing is actually possible. But all code has at least one test. That's when the poor user sits down and fires it up and tries to do something useful with it. Right? We endeavor to do as many tests before that as we can, but it's not always possible. But the point is, really, that the code we're going to be looking at today has no tests. Right? How many people are familiar with this acronym, YAGNI? Right? You aren't going to need it. How many people are familiar with this game, by the way? Interesting. Okay, so we're not yet at the point where everyone goes, yeah, it's not digital, I don't know what that is, right? So, this is, of course, the game Mousetrap. And anybody who's ever played this game knows that part of the challenge is, of course, winning the game. The other part of the challenge is not accidentally nudging the table that the game sits on top of and triggering the mousetrap to fall down when you're actually really just trying to roll the dice for the next move. The point is, this is obviously not a better mousetrap. Right? And this is obviously tongue-in-cheek. But the point is, we've all worked in software systems like this, where over time, we do think we built a better mousetrap, and it ends up, of course, sadly looking like that. Right? The idea behind YAGNI is a notion that you're not going to need it, and more importantly, don't build it until you discover you do need it. Right? Which is to say, don't start out with an architecture diagram for your software that says we're going to build that. Right? Start out with something much simpler, and as you discover that some of this complexity is actually beneficial to you, add it. Right? What's missing here is there really needs to be a Y on the end of this. You're not going to need it yet. Because sometimes you do need this complexity. Right? But don't add it up front, assuming you're going to need it. We've all worked on the software system that's driven by 300 configuration files that govern the behavior of every little last iota of code in the system. Right? When that's done poorly, we call it an overamped configuration system. When it's done semi-poorly, we call it a business rules engine. The point is, we've all worked on these systems. They basically do nothing until you tweak a configuration file somewhere that really tells the software what to do, right? Sometimes that complexity is beneficial, but more often than not, that's because a bunch of ivory tower guys sat down and said, how can we write this so that we never have to write it again? Ever. And the answer, of course, is externalize all the behavior and configuration files that some business guy can fire up in Excel, right? But don't start this way. At least try not to. Tight coupling. We've probably all dealt with this problem at some point in our lives. Tight coupling is the scenario where someone says, I would like this submit button on this form to be blue instead of red. And so you change it from red to blue, and all of a sudden the sort order on the report is backwards. Now, that's probably not intended. We probably didn't mean that the color should control that, but the reality is somebody accidentally did. Right? A change over here is felt way over here. And there are a couple of reasons why that's problematic. The first reason it's problematic, of course, is that it introduces bugs. But the other reason it's problematic is that if we think about the problems of testing legacy code, right? Eventually you reach a point where the size of your system is so large that what do? You make a change and you don't test it. Because the friction of testing it is so great that you're just going to say, not worth testing it. but I'm going to make the change over here. And I'm going to assume that changing the color of that button doesn't change the sort order of the report. Right? This is an insidious problem that invades all software systems to varying degrees. And just like the ripples on the pond where we drop a stone here and the ripple is felt all the way on the opposite shore, right? It's like flapping the wings of the butterfly. We want to avoid this wherever possible. We want to explicitly take steps to avoid this problem. Here's another one. Even though this doesn't use the acronym, this one has an awesome acronym. Forget the acronym, which thank God has vowels in the right place. But this one, at least, don't repeat yourself. Dry. Your code should be dry. Because who wants soggy code? This is often interpreted to mean don't copy and paste your code around. Don't copy and paste your code around. But that's not really all it means, right? When we think about don't repeat yourself, what we really mean is if I've got a method over here and I need a new method that does 90% of the same things, what I shouldn't do is copy the first method and paste it over here and change the true to false and call myself done, right? But more importantly, what don't repeat yourself really means is don't repeat important concepts in your software. Not just don't copy paste code, but don't repeat important concepts. So let's take an example. Let's imagine that we have that software that is driven by configuration files. And let's imagine that instead of an onerous number of configuration files, it's just one configuration file. Lots of software works this way. That config file contains your database connection string, or who knows what the heck else, right? What we shouldn't do is we shouldn't have every module in the system that needs to know how to read the config file, know how to read the config file, know where the config file is located, know what the name of the config file is, know what the structure of the data in the config file is, and so on, right? Why? Because if any of those things need to change, then the software is broken in 46 places. Because we took an important concept, reading data out of a config file, and repeated it over and over and over again throughout our code. Right? Whether we copied and pasted it or not, or whether Team A wrote a config file parser and Team B wrote a config file parser, it doesn't matter whether they copied from each other. The point is the concept of parsing data out of that config file is repeated ad nauseum throughout our software system. Right? Another great acronym for which I don't have a slide is SPOT. Single point of truth. For every important piece of information that your software system needs, there should be a single point of truth for that. And everybody should know where to go to get that. Right? So that if where that single point of truth is needs to change, only one place has to change. Right? So dry certainly means don't overuse your clipboard when you're developing software. Right? But it also means don't repeat concepts. Right? Don't have 6 different config file readers, each one slightly different. That leads to fun stuff, like how come this part of the system is writing data to the production database, but this part of the system is somehow logging the activity log in the QA database? Because they're both reading a config file with a slightly different name and a slightly different structure. Right? That's what we want to avoid. How many people know the story about how you boil a frog? You don't have to have actually boiled a frog, by the way. This is not like a come to Jesus meeting where you apologize for boiling frogs as a kid, okay? So, you do not boil a frog by creating a pot of boiling water and tossing the frog in. Why? Because even though the frog has a brain much smaller than me, the frog is not as stupid, right? The frog says, ouch, boiling water, I should leap to safety. And this is in fact what the frog will do, right? The way you boil a frog is you place a frog in a pot of room temperature water and you turn up the heat, slowly. And slowly but surely the water reaches a boil, but the frog never notices because it happens slowly over time. This is how you boil a frog, right? If lobsters were more spry, it's how we'd also boil lobsters. Lobsters can't leap, and we chain them up anyway before we drop them to their death, so we don't have to worry about that when boiling lobsters. But when boiling a frog, that's actually how you do it. So this is also how our code goes bad. None of us, at least those of us that show up for meetings like this, come to work in the morning saying to themselves, today, my plan is to write the most obtuse, impenetrable, incomprehensible, complicated piece of software I possibly can, so that no one else on my team will stand a chance of maintaining it, and my job will be safe and secure. Because the number of unmanageable systems that are out there suggests that that strategy will never succeed, because you still get fired. I know, right? I used to do consulting for a living, and I was called in to fix a lot of those systems, right? So that plan does not work. And most of us in this room don't even try that plan, right? So we don't show up in the morning saying we're going to write awful code. But it happens. It happens slowly over time, right? What we often want to try to do, right, the inverse of this is when we all go into a meeting and go, nobody can manage this system. We can't add another feature. It's crushing under its own weight. You know what we should do now? Rewrite it. Let's rewrite it. Who's in? But that's how we get there from here, right? We start out saying we're going to write good code, and then discipline starts to suffer. And we start to cut corners. We get what's called technical debt, right? This isn't a talk about technical debt, but many of us have heard that term, right? Slowly but surely our software goes bad over time. But we don't notice it because it happens very slowly, day by day, little bit by little bit. Our goal should be simplicity. What most people think, right, is that simplicity means simple. Not true. Simplicity is a comment about clarity. Sometimes, the only way to solve a problem is in fact in a complex manner. Usually much more difficult than just pointing to X. But the point is, we want to strive for simplicity. We want to solve the problem with clarity, in the clearest way possible. We're going to be using some refactoring tools in today's talk. I just thought this was kind of a cute graphic. I have no idea what it was intended for. But I thought it made a good slide. So we are going to be using some refactoring tools in tonight's talk. Some examples, right, for the .NET platform. Some of us are on that here. Developer Express makes a product called CodeRush. JetBrains makes a product called ReSharper, which is in red because it turns out to be the one I'm going to be using today. Telerik makes one called Just Code. Visual Studio Professional has its own refactoring tools built in. And also you can do refactoring with Notepad, right? And the point isn't that Notepad is a great refactoring tool. The point is that you can do refactoring without any of these tools, right? Refactoring is a mindset. It's not a tool. Just like writing code is a mindset. It's not an IDE, right? You can do these things without the tools. They're a way of thinking about the problem. As with most tools, some work is easier with a tool. I can build a house without a hammer, but it's a hell of a lot easier if I have one. But the point is, I know how to build a house, and having a hammer doesn't help me there. If I just have the hammer, it doesn't make me able to build a house, right? I need the knowledge of how to build that house. So the point here is that even though I'm going to be using refactoring tools, the thing to keep in mind today is that they're not a prerequisite for this process by any means, right? So don't walk away from this saying, I can't afford refactoring tools at work, which is a whole other ROI, bad judgment choice of yours. But if you leave here saying that, right, don't conclude that you can't use any of the techniques that are seen here. So, how many people in this room are familiar with the game Jenga? All right. For the couple that did not raise their hands, very quickly, Jenga works like this. We start out by building a tower of wooden blocks, all of them identical, right? Resting on top of each other, held together by nothing but friction and gravity. One by one, we go around the group. And one by one, we take turns pulling a wooden block out of the tower.
We make that out of cards.
We
call it the card house.
Yes, same game, right?
House of Cards.
House of Cards, right? So, very interesting allegories between Jenga and software development. How do you win at Jenga? By not losing. How do you win at software development? You become the guy that doesn't put the failing bug in the code. Right? You don't win by being good at Jenga. You win by being better than at least one other person in the room. That's all that's necessary to win at Jenga. Right? It's like the four campers being attacked by the bear. I don't have to be faster than the bear, I just got to be faster than the slowest guy with me. Right? Same idea. Too often we approach software development with exactly this mindset. Right? If I can just get out of here without introducing that bug, if I can just make sure that somebody looks worse than me, if I'm not the one who's unlucky enough to prick the wrong block out of the stack and make the entire software system crumble at my feet, then I'm a success. Right? We shouldn't win at software engineering by not losing. We should win by winning. So, this takes us to solid. Because we're software developers, we love obfuscation, we love abstractions. So solid, because it's got periods after each one of the letters, is, as you can see, an acronym. Because we love abstraction, solid is actually not just an acronym, but it's actually an acronym of acronyms. So the S is for SRP, the O is for OCP, the L for LSP, the I for ISP, and the D for DIP. So, everybody got that? So, we're going to dig into these though. SRP is an acronym itself for something called the Single Responsibility Principle. OCP is an acronym for the Open-Close Principle. LSP is an acronym for the Liskov Substitution Principle. ISP is short for the Interface Segregation Principle. DIP is short for the Dependency Inversion Principle. The good news is since all of these end in P, we can sort of immediately simplify this down and drop the P's. So we got single responsibility, open close, Liskov substitution, interface segregation, and dependency inversion. So what we're going to do today, or tonight as the case may be, is we're going to take a look at a straightforward piece of software that is reasonably well engineered to begin with. And one by one, we're going to improve its design by applying these principles. As we do so, we'll discuss what they are, what they mean, and why we should care. Let's start with the single responsibility principle. So, if I were to be trapped on a desert island with no hope of immediate rescue, and someone said to me, "What tool would you like to have with you?" Objectively, a lot of us would say that one. Because no matter what happens to me, I'm ready. Right? If a bottle of wine washes up on the beach, I got a corkscrew. If I manage to catch a fish, I can probably scale it. If I break a nail scaling the fish, I can probably clip it and file it. Right? All of these things are possible with this tool. And if I get a nail stuck in my foot, I can use the pliers and pull it out. I'm all set. We've probably all, well, before we talk about that, right? But the reality is there's a problem with this, right? The problem with this is that even though it does all of those things, it scales fish, it's got a saw so I can make firewood, I can trim my toenails, I can open a wine bottle, I can do all these things with it. The problem is that it's not actually any good at any of those things, right? It's not the best corkscrew on earth, it's not the best nail file on earth, it's not the best pair of pliers on earth, it's not the best fish scaler on earth, right? It's not really great at any of those things because it's trying to do all these things. We've all dealt with this piece of software in our code before. It's when you walk up to the object and you type its name and you hit dot. And IntelliSense goes like this. And just keeps going and going and going. And then your IDE gives a stack overflow and says, forget it, there are just too many methods on this thing, I give up. We've all dealt with this object. The problem is that it tries to do too many things. And because it tries to do too many things, it does none of them well. Anytime anything has to do more than one thing, anything, the way it will do both of those things is a compromise. Because doing the one thing, it can just focus on that. As soon as you add the second thing, now they have to collaborate together, they have to live together, they have to coexist. Right? And so neither will be the best at what they do because they're going to be giving concessions to their next door neighbor. Anything will be influenced by its proximity to something else, especially in software. So, the single responsibility principle is an attempt to solve this problem. Single responsibility principle says there should never be more than one reason for a class to change. Why do we say it this way? Well, first of all, because if we said that the definition was everything should have a single responsibility, we have a very strange sort of logical tautology going on, right? So what we say instead is there should never be more than one reason for a class to change. And part of the reason for that is that if we follow that, we will end up with classes with single responsibilities. Let's actually look at this in demo that'll make it a little bit more coherent for us. And yes, I know I'm not at the optimal resolution. Okay, here we have a very simple software system. In fact, let's look at the class diagram. Here is our class diagram. This is a console app, so that explains the program class. Don't pay attention to that. We've got just one object that's called report. And it's got a method. It's got methods in it called format report, get data, and print. Let's run the app so that we can see what it actually does. All right. Okay. So we get data from a database. We format it for an 8.5 by 11 piece of paper, and we print it to a laser print. Success. Now, let's look at the code. Inside the program class, what could be simpler? I would like to print a report. Let's new one up and call print on it. Done. Very, very simple and straightforward, easy to understand, easy for a consumer of the object to understand. It might even feel to us like really good encapsulation, right? Part of OO is encapsulation, the idea of hiding, right? What could be more hidden than the fact that I call print and 1,000 things magically occur? Who knows what they are? But maybe just because I want to print a report, I shouldn't know or have to care. So we feel on some level that this is actually not a bad design. If we look at the definition for the print method, we can see that it calls a private method get data and a private method format report, and then of course just prints this out to a laser printer. So decent encapsulation, one public method, a bunch of private stuff, some data hiding, feels good from an OO point of view. Unfortunately, it's a huge violator of the single responsibility principle. Right? Remember, there should never be more than one reason for a class to change. What if, instead of getting data from the database, we want to read data from an XML file? This class must change. What if, instead of printing to an 8.5 by 11 piece of paper, we want to print to an 11 by 17 piece of paper? This class must change. What if, instead of printing to a laser printer, we want to print to some other printer? Again, this class must change, right? So very clearly, based on single responsibility principle, this thing has got too many responsibilities. It's doing too much. So let's refactor this a little bit in order to sort of fix this problem. So what we want to do is we want to create classes to hold the various different responsibilities. So let's create one called, oops, sorry, get the caps lock on, data access, and we'll make it public. We're going to take our get data method, we're going to put it up here, and we'll make it public so we can get at it. Our next responsibility is report formatting. So let's create a class called report formatter. What could be simpler? Let's take that method, put it up there, again make it public so we can get at it.
Public down term.
Yes, thank you. That's what we call multi-person pair programming. And our last responsibility is report printing. So by all means, let's create a report printer and similarly make it public. So this guy is going to need a public void method we'll call print, like so. And we're going to, oops, sorry, a little bit too much scrolling. We're going to take this line and we're going to put it up there. Now, problem is this thing is horribly broken right now. Right? Won't even compile, all kinds of things are broken. So what we need to do is fix that. So we're going to solve this by coming in here and saying, well, when it's time to get data, let's do so by getting ourselves a new data access instance. By all means, let's set it to a variable. And when it comes time to get data, we'll ask our data access component to do the work, like that. Similarly, when we need to format the data, we'll new up a report formatter, like so. And we'll ask our report formatter to actually format the report. And when it comes time to print, we'll ask for a new report printer. And we will also introduce a variable there. and we'll say report printer.print. Now let's see if we can compile it. Sure enough, it works. Let's run the code and see. Get data from a database, format for 8.5 by 11, print to a laser printer, right? We have no tests, so we have to run the software. It's our only choice, right? Fortunately, our software is really easy to verify it's working. Somebody just goes and stands in front of the printer tray and says, "Do we get something?" The answer is yes, right? So, success. Okay. Now, what I'm going to do is I'm going to take these classes and I'm going to move them to other files. For no particularly good reason other than I want to get them on the class diagram canvas. And to my knowledge, there is no way to do that that doesn't involve getting them in separate files first. Okay, so once we do that, it's possible to come over here and take our data access and our report formatter and our report printer and add them to the canvas here. Okay, so we have our program. And what happened to data access, report, oh, what happened to report printer? Sorry, missed one. Come over here. Okay, so what happens is our program asks our, let's just lay that out. Data access, program, report format, what am I missing?
Report.
Yes, no, yeah. No, I have report, don't I? No. Hold on. Maybe you're right, somehow I lost the report. Have that get off the canvas. There we go. So let's try this way. So what we're going to do is we're going to arrange the class diagram into a rough sequence diagram. So we have a program that calls report, that asks data access to do some work, that asks formatter to format, and then that asks printer to print. So we look at this and we say to ourselves, this is a lot more complicated than the class diagram we had before. Before we just had a report method, right? A report class, and one method on it was public. Now we got all kinds of other things moving around here, right? So how can this possibly be better? Well, let's imagine. Let's imagine that it's Monday morning and we've hired an intern. The intern's first job is to change the margins on the report. Where do we go to do that? Report format, right? Whose job is it to format the report? Report formatter. With this class diagram, what are the odds that while the intern is changing the margins, data access will break? Probably not zero, but really close to zero, right? Once we've got code working, what's the best way to make sure it remains working?
Don't touch it.
Exactly, don't touch it again. Don't open it for editing, don't check it out of source control, don't look at it cross-eyed, just leave it alone. It's really easy for us to isolate work in this system now. The intern can go working on report formatting while our data access team is changing the whole way we read from our database. Independent of each other. More importantly, right, just from a work management point of view, with the old class diagram, what are the chances that the data access team can be working on the code base at the same time the intern is changing the margins? Without an interesting merge scenario at the end. What are the odds the intern we just hired is capable of resolving the merge conflicts? Not high, right? So, while it seems on its surface that this is a more complicated software system that we've just refactored to, the reality is that if we imagine this as more complex behavior, imagine that data access isn't just a class with one method, but it's obviously a class with a lot more code in it. Imagine that report formatting isn't just saying, congratulations, we formatted it for 8.5 by 11, but also calculates margins, does pagination, does headers and footers, and all kinds of other fun stuff, right? We can start to see how this divide and conquer approach makes a whole lot more maintainable software system, right? And that's really what we're shooting for here. Clarity, right? Simplicity is not simple. Simplicity is clarity. Clarity of where the behavior is, clarity of where the boundaries are, clarity of what the relationships between things are. Okay. Our next principle is the open-close principle. The open-close principle is kind of an interesting one because what it really says is that simple things ought to be simple to achieve. Which feels feels like what we should be shooting for anyway, right? But the idea is that if you want to do something simple, like put on a coat, chest surgery shouldn't be required for this, right? Major surgery shouldn't be required for a minor operation. So what's the open-close principle actually say? Software entities, classes, modules, functions, etc., should be open for extension but closed for modification. This feels like one of those bad sort of software engineering fortune cookies you get. And you say, ah, very wise. And then you think about it again and go, wait, what? How is that supposed to work? So let's look at this in a demo. Remembering that open for extension but closed for modification is what we're targeting here. So let's look at this in code to bring some clarity to this. Okay, so here's our scenario. We still got our old code base from before, and these reports, by the way, what we're doing is a little backstory, right? We're printing reports for our CEO. These are our financial reports. Our CEO does an awful lot of flying on airplanes. He's on a flight. Sitting next to him in first class is another CEO. Our CEO pulls out his 8.5 by 11 financial reports and flipping through them. We're pretty profitable, so he's feeling pretty good about himself. Looks over at the seat next to him where the other CEO is, and that CEO has this big, giant 11 by 17 report. Doesn't really matter what the numbers are. Our CEO suddenly has report envy. We are every bit as important as that company. How come my reports are smaller? Comes back from the flight, calls an all-hands IT meeting. Everybody in here immediately, we have a crisis facing this company, we must deal with it immediately. Our reports must be 11 by 17. Who's worked for this guy, by the way? All right. So, our IT department goes back into the room and huddles up and says, this is really important to the CEO, but to be honest with you, we all know this is just sort of a game we're playing. So, let's give it to the intern. Because we're really working on secret project X, and we know that's much more important. And when the CEO wises up 2 weeks from Thursday, he's going to realize that and ask why we're not done with project X. So let's keep working on project X, give the intern this one. So the intern says, well, this is pretty easy. Because in my class diagram, I know that if I need to change the way we print, the answer to do that is to open up the report formatter class. And the intern goes, guys, I got this. I can even run it through QA. Let's take an early lunch. Flush with the first success. Our intern report's done, closes the bug in the bug tracker, and we're all happy. However, we just violated the open-close principle. Didn't we say software modules should be closed for modification? Well, we just modified it. So this is not how to solve this problem. So let's go back to our source control system and revert that check-in. First of all, it's got the intern's name on it, so the odds are pretty high it's going to be reverted anyway, but we're going to revert that check-in. So, if it's closed for modification, then we have to open it for extension. Somehow. There are many ways to do this. We're going to use one. We're going to create a derived type, and we're going to call it tabloid report formatting. And we're going to inherit from report formatter. That's a good start, but we need to open this class for extension. Let's do so by adding, really? Oh, yeah, actually. So note to self, the virtual keyword works great on methods, but not so great on class declarations. So now this class is actually open for extension, right? In C#, what does virtual mean, right? It means method can be overridden in a derived type, right? Without that, it can't be, right? For any of the Java devs in the room, we know this as the reverse problem, right? In Java, everything is overridable in the derived type. So by default, everything is actually open for extension. An interesting difference in philosophies about design platforms, right? Here we have to be explicit about it in the C# world. In Java, we get virtual for free. So, well, not quite, of course, right? But we get it by default. Here we have to actually explicitly say, this part of my class is open for extension. So now that we've done that, it's actually possible, of course, to come down here and change this. let's override format report, and instead of calling the base action, we are now going to do what I told you not to do, which is copy and paste. But I'm copying and pasting because I don't want you to have to watch me write that code. Imagine that the code is much more complicated. Imagine that there are margins, pagination, headers, footers, all kinds of other fun stuff, right? We only need to override the part that actually formats the page. Right? That's what we're doing. So, now what we do is we say, okay, we got that part, let's run it. Damn, still 8.5 by 11. Well, why, right? Because, of course, creating a class doesn't really solve the problem in and of itself, right? If we go back to our report, we'll notice that our report is still using the original report format. So we actually need to change this to use the tabulated report formatter. And run it again. Now we have 11 by 17. Except we have another problem. And that is that we just violated the open close principle. I just modified this code. I'm not supposed to do that. So let's undo that, because that's not how we're going to solve it. And instead, let's extend this guy. Same way. We're going to create a new class called tabulate report. We need to open this for extension, so we'll make it virtual so we can override it. And down here, we will in fact override print. And instead of the base action, we're actually going to borrow this guy. Once again, following the copy-paste principle, which I told you not to follow. Let's run the code now. Still 8.5 by 11. What went wrong? Well, of course, in our program, we're still using the original report. Let's change that. Tabulate report. Wait, 8.5 by 11. What happened?
Couldn't paste.
That's right. I forgot to change it, right? Tabulate format. Now let's run it. 11 by 17, right? We found our first bug by running our software. It works. Now, a lot of us will look at this and say, why didn't we just edit the formatter? It would have been a lot easier, right? Our CEO goes on another plane trip. Because he's a CEO, he likes first class. But, you know, you can't always get first class. Sometimes it's booked. Our CEO ends up in coach. He needs to look at his financials. So he pulls out his 11 by 17 reports. There's not enough room in coach to read these damn things. I'm bumping elbows with the cattle back here with me. I can't view my report. This is ridiculous. I come back from my flight. IT, we got to have like an all hands again. We got a real problem here. It's an existential crisis facing our organization. We have to also have 8.5 by 11 reports. I'm just telling you right now. This company was built on the idea of multi-size reports. We must have them. Okay, no problem at all. We got this. CEO's very happy. Right? We can imagine a scenario, in fact, where instead of editing the console app, we actually provide a menu that asks CEO, you be traveling in coach or first class? And prints the appropriate size reports for his journey. Right? The point is that we don't lose the flexibility by adding capability. Right? We have working code tested, thoroughly vetted, behaviorally correct. Let's not throw it out. If we didn't do what we just did, how would we solve this problem? We go back to our source control system, try and correlate it to the date that the bug was closed, and the check-in that matched when the bug was closed. Figure out how we can roll back that code and then merge it back into the mainline branch with all the features that have been added since, and try and resolve all that in order to get the old functionality back. Who's been down that path? Right? We all have. That's software engineering. Right? The point is we'd like to avoid that. So we're very happy with ourselves until we get a call from our printer support group. Calls and says all the print servers are crashing because their queues are all full of unprintable documents. Why is this? Well, we look into it. It turns out that the print queues are all jammed full of 11 by 17 printouts destined for a laser printer with no 11 by 17 tray. So, We realize that this, of course, is because our tabulated report uses the report printer, which uses this laser printer. We need to extend this behavior as well, so let's do so. Create a derived type called tabloid report printer. Let's open this for extension by making it overridable. I'm going to borrow this code, and then we're going to override print, and instead of the base behavior, we're going to put that in. And now, if we go back to our tabulated report and make its printer use the tabulated report printer, we can now print 8.5 by 11 to the laser printer. And actually, there was one part we missed. Instead of printing the laser printer, we need to actually print to a dot matrix printer. Any people in the room are old enough to remember dot matrix printers? I feel so much better. Okay, so now if we go to our program, if instead of printing a report, we print a tabloid report, we get 11 by 17 in the dot matrix. IT is happy, our print services support group is very happy, everybody's happy. It's a win-win, win-win-win, win-win-win-win, win-win. Success. That's the open-close principle. Yes?
Seems like sometimes making something overridable or virtual is almost going against open close, because you're sort of encouraging people to take your code and undo or redo whatever that method might have been doing. I mean, I guess maybe in a more complicated example, you would have a method that didn't change and then it called one method which is intended to be overridden.
Yep.
So I guess that's just what it was. Yeah.
Well, and the point, right, and this is actually one of the reasons why there are benefits to the fact that in Java everything is overridable by default in the base, in the subclass, versus not, right? But there are also downsides, right? So in .NET, for example, I have to explicitly, as the designer of that class, say, this is an extensibility point. This is an intentional extensibility point. I am expecting that the code I'm writing in this method may or may not actually ever be fired, right? Because in your derived type, you can choose whether to invoke the base implementation at the end of your own override or not, for example, or in the middle for that matter, right? So it allows you as the designer of that object to be more intentional about where the extensibility points are, right? In Java, you actually have to be literal about where the extensibility points aren't, right? It's just a different philosophy, right? So I am not suggesting that in order to guard and future-proof your code, what you do is you put virtual on everything, right? What I'm saying is be thinking about future uses of your code and future extensibility points, because if you don't provide them, right, then I can't use them, right? So be thinking about that as you're designing your code, right? But very good question, right? And by the way, there are other ways than virtual to leave classes or objects open for extension, right? So in a lot of languages, .NET 2 for that matter now, right? There's a tremendous There's a tremendous new attraction to function passing, right? Which is difficult to call new, of course, because it's a very old concept. But conceptually, right? By saying plug this delegate in here, plug this function in here, replace this behavior with that behavior, right? Those are other ways to extend that don't necessarily mean virtual, derive, and override, right? There are lots of other extensibility mechanisms that you can use, not just in .NET, but also in other languages too, right? And the point here really isn't so much the implementation as it is be thinking about it, right? It's the mindset. There are lots of different ways that different platforms give you to make your classes open for extension. That's the first half of, or maybe it's the second half, right? It's one half of the open-close principle, right? So as soon as you say, nope, that's it, I'm closed for modification, once I'm done and I'm working hands-off, except for these extensibility points, that I am explicitly as the object designer saying, these are the places where I'm going to say it's okay for behavior to change, right? Yeah.
And wasn't there another part of that as well where you need to look at what you're actually looking forward to extending? So the formatting example that we saw, where we had to repeat the code going into the formatting for 8.5 by 11, theoretically, were that a more complex system? You break off the 8.5 by 11 portion to be its own get size method or something like that could be overridden, maintaining the base print method.
Right.
You wouldn't be rewriting that much of it.
Yeah, yes, absolutely, right? So we're a victim of So the challenge here, right, is that we need a software system that is complex enough to talk about the principles, but not so complicated that you watch me write code for 2 hours and that's it, right?
Right.
And so you're entirely right, right? The actual implementation here in most real world scenarios is much more complex, right? And for that matter, nuanced, right? But the decision process is the same, right? And it's really, the important part of that principle is apply it to your object design, right? Apply it to your code design. Be thinking about how someone will extend the behavior of this, right? So our next one up is the Liskov substitution principle. If it looks like a duck and quacks like a duck, but needs batteries, you probably have the wrong abstraction, right? So this is a take on the comment, if it looks like a duck and quacks like a duck, then it's probably a duck. But the reality is that on some level, we can actually look at these two things and say they are clearly both ducks. And yet they are and they aren't, right? They probably both have a swim method, and when we invoke it, it probably does something quite similar. Maybe not quite the same, but certainly something quite similar. One of them probably has a charge batteries method. You can obviously guess which one. But one of them probably has a sleep method. They might both have sleep methods, but they probably do very different things. Right? One, when you call sleep, nothing else works. Listen for sound doesn't work. Smell for predators doesn't work. Keep from sinking doesn't work. But another one, when you call sleep, all those other behaviors are actually still there. Right? So even though from the outside we may agree that both of these have a sleep method on them, it turns out that it does matter quite a bit which duck you're calling sleep on. Right? So the Liskov substitution principle is named after, who knows? Barbara Liskov, quite right. So for those of you non-CS historians in the room, right? Barbara Liskov was an absolute computer genius. One of the, it's not even fair to say women pioneers in computer science. She was one of the pioneers of computer science. We're talking about way back in the 40s and 50s, right? And really, I mean, did wonders for the state of software engineering as we know it today, right? Huge contributor to the body of knowledge that we know of. She was a very highly credentialed computer scientist. And she wrote like a very highly credentialed computer scientist. This is the Liskov substitution principle. If for each object O sub 1 of type S, there is an object O sub 2 of type T, such that for all programs P defined in terms of T, the behavior of P is unchanged when O sub 1 is substituted for O sub 2, then S is a subtype of T. Everybody got that? So, this is the kind of thing that makes my head hurt. Because it's probably correct. In fact, because Barbara Liskov wrote it, I'm nearly certain that it's correct. What I am certain of, by the way, is that I am definitely not qualified to challenge its accuracy. However, if you're like me, you have one reaction to this. I'm sure it says something really important, but I have no idea what it is. Fortunately, we can rewrite the Liskov substitution principle in normal human being speak. Functions that use pointers or references to base classes must be able to use objects of derived classes without knowing it. Now, the first part of this, functions that use pointers or references to base classes must be able to use objects of derived classes, it doesn't seem terribly important. Because if you think about it for a moment, all it really is what we know today as polymorphism. Right? This is true of any polymorphic OO language. Right? We can always use derived types in place of supertypes. That's the whole point of polymorphism. The important part of the Liskov substitution principle is what Barbara Liskov is saying is that when you do that substitution, you have to be able to do it without knowing you're doing it. Without the code that consumes the object knowing. So, if you have a method in your code that takes an argument of a particular type. And inside that method body, you have code that says, if argument is really this type, then that. Else, do something else. You are violating the Liskov substitution principle, right? Your code does know and does care whether what it's getting is a superclass or a subclass or a subclass, because you're testing for the actual type. The trick is that the invoker of that method has no idea that you care, right? And so the fact that the method signature says I can pass this type or any subtype of that, but when I pass this type I get one behavior out of your method, and I pass a subtype I get a whole other behavior out of your method, that violates the Liskov substitution principle, right? So when we are doing that, it's a problem. Let's look at this in actual code samples. So the fun thing about the Liskov substitution principle, and actually this is true, by the way, really of all the principles, is that it would be awesome, in my opinion, if you could get a compiler error when you violated one of these principles. Right? How cool would that be? Right? Error! On line 467, you violated the single responsibility principle. That would be awesome. At least I think so. The truth is, none of us will ever be able to compile anything ever again, right? But the point is, right, that violations of these principles don't result in compiler errors. It'd be pretty cool if they did. And I'm going to show you how we can actually almost accomplish that. And it begins with a little trip down memory lane. When you were learning how to write software, all of us, at some point, had someone tell us, it really matters what you name stuff. It really matters. And you said to yourself, well, yeah, but then how come all these for loops have i's and j's and k's? I mean, you're just full of it. That's not real. Obviously, it doesn't matter what you name stuff, otherwise my iterator wouldn't be called I. It'd be called iterator. But the point is, at some point, somebody told us this. It matters what you name things. It actually does matter what you name things, and I'll show you why. Inside this code right now, we have, all the way up here, code that reads like this. Report equals new tablet report. We look at that and we say, that makes sense. On a report on the left side, I get a specialized instance of report on the right side. It makes sense, right? Report equals new tablet report, reads good, everything's cool, right? So it turns out we have a problem in our naming. Tabloid report is this very specialized instance of report that prints 8.5 or prints 11 by 17, uses a dot matrix printer, does all these specialized things. What about report? Well, report's actually just as specialized. It prints 8.5 by 11. It prints to a laser printer. It's no less specialized than the tabloid report printer or the tabloid report. Why have we not given it a specialized name? So let's do that. One of the reasons why it doesn't matter what you name things, by the way, is that the rename refactoring is one of the safest, most valuable refactorings you can ever employ. Very few things that don't somewhere buried deep in your code using reflection where it shouldn't be will break if you rename things, right? So in a sense, it does matter what you name things, but you shouldn't be afraid to rename things. So let's do that. Let's take this guy and rename him letter report. And I'm actually not going to say rename the related symbols because that will defeat the point of this exercise. Let's not have the refactoring tool clean up the mess I'm about to make. Now let's go back to our code. That makes no sense at all. Letter report equals tablet report. Huh? Now what's interesting is the compiler is actually quite happy with this. It'll compile, it'll run, because the compiler doesn't say error, you violated the Liskov substitution principle. Your sentence makes no sense. Letter report equals tabloid report. Right? This is why naming things matters, because if you didn't bother to name letter report and letter report, just left it as report, you never notice this problem. But what this code says is that anywhere this code expects a letter report, it's perfectly valid to give me a tabloid report instead. Really? Really? to believe. When we call print here, we're going to get twice as many pages out of the letter report as we are out of the tabloid report. Where's the code that calculates to figure out whether or not we got enough paper in the paper tray? Is it going to respond the same way whether I've got a letter report or a tabloid report? Probably not. But the compiler is quite happy with this. But the important point is that as we get specific about this naming, what we realize is that this sentence, as we read it aloud to ourselves, no longer makes lexical sense. It just doesn't read right. When we see that, it's the first clue that we are about to violate the Liskov substitution principle. And this is why naming matters so much. Because if you're not careful about naming, then you're missing this clue in your code. Right? You're missing this guidepost along the way. It turns out that we actually have this problem elsewhere too. And if my mouse will wake up. Okay, go into touchpad. Weird. Okay, now it's working. Report formatter has the same problem. Tabloid report formatter is very specific, right? But report formatter is actually very general. Let's fix that. And let's not do that. Now, if we look at tabloid report, we see the same problem manifest itself. Letter report formatter equals new tabloid report formatter. This is equally wrong sounding. Is it really the case that this code doesn't care? It seems really odd the way we built this. When you start seeing this kind of thing manifest itself over and over again, what you begin to realize, more often than not, is your code is actually missing a concept. Right? And that concept is report. Not letter report, not tabloid report, but report. So, if we solve this problem at the report level, oops, sorry, wrong key. Let's go to letter report, like so. What we're going to do is we're actually going to introduce a report concept to our code base. So let's do so. We are going to extract superclass. And we're going to call our superclass report, not letter report base as it seems to want to. And just because we can, not because we have to, we're going to go on ahead and make the member abstract. So now what we have is letter report inherits from report, which is this abstract base class. This actually allows us to come into the tabloid report, go back to the program and change this. Actually, hold on a second. Before we change that, let's actually also change the tabloid reporting to also derive from the base class. So this makes sense. Our specific instance of letter report derives from our abstract report. Our specific instance of tabloid report derives from our abstract report. Now look at what happens when I actually try and compile this. Uh-oh, build errors. There's one. Lo and behold, the compiler now tells me that I'm violating the Liskov substitution principle, right? Because this sentence that didn't used to make any sense now won't even compile. That should be our goal. Code that doesn't make sense should not compile. That's what we'd like. In order to make this code make sense and also make it compile, we need to actually change the left-hand side of this assignment to be report, right? Now we can have code like this that runs 11 by 17 dot matrix printer. And also, if our CEO picks the other choice, letter report, it also compiles 8.5 by 11 and laser printer, right? The important point here, right? And we have this exact same problem, by the way, elsewhere in our code base, right? We have this exact same problem with the letter report formatter, which needs a superclass, because again, there's a missing common concept, this common concept of report formatter, which will do that too. And our tabloid report formatter will no longer inherit from letter, but just a plain one. And now if we compile, we should again get errors, right? And our error is down here in the tabloid report. This code that doesn't really make sense as a sentence no longer will compile either. So by all means, let's fix that. Let's do that. We have exactly the same problem with report printer. Let's quickly extract a superclass here. And we'll call it not report printer base, that's for sure. Oh, I got, sorry, got two of these guys. This guy needs to be renamed first. Letter report printer. Don't do that. And now we can extract the superclass. Should have known something was up when I didn't put letter in front of it. Okay, and we can fix this inheritance as well. And now if we compile it, it still won't work. But again, our error is exactly where we want it to be, where the code makes no sense. So let's do that. Now, the other thing we're going to do though is we're going to look at the letter report. And we're going to make these more general as well. In the interest of consistency. Now our code compiles and it builds. We are not doing erroneous substitution of types in really weird places. Right? Because what we noticed from the Liskov substitution principle is that as soon as we were specific about naming things, as soon as we were equivalent about naming things, we followed consistency, right? If we have a specialized tabloid report, we should have a specialized letter report, not just any old report and a tabloid report, right? As soon as we are more specific about our naming, problems like this begin to show up in our code. If we are lazy about things and call them X at X1 and X2 and X3, we never notice these problems. It's one of the reasons why it definitely matters what you name things, but you should not be afraid of renaming things. Renaming things helps you evidence problems like this in your code base, right? As we just saw here. As soon as I'm accurate with names, code that compiles just doesn't make logical sense anymore. Okay, next up is the interface segregation principle. So, if I have this USB cable and I want to plug it in there, I don't know what the heck to do. Certainly there are lots of places I can plug it in there, right? But am I supposed to press and hold the red button and then insert the cable? Am I supposed to flip the switch to the left or the right and then insert the cable? Maybe turn the key counterclockwise, a quarter turn, who knows? But if I've got this plug and want to plug it in there, I've got to learn everything about that complicated box in order to figure out how to plug this thing in. This is the problem we're trying to solve, the interface segregation principle. Really, really simple idea. Clients should not be forced to depend upon interfaces that they do not use. In this particular case, we do not necessarily mean an actual interface, right? Which is to say, not the code construct interface. What we mean is, by interface, we mean public API, right? How many people here have done ASP.NET programming at some point in their lives? Okay. How many of you are familiar with the ASP.NET membership provider? How many people have implemented their own ASP.NET membership provider? How many of you have implemented all of the methods? Nobody does, right? That's because the ASP.NET membership provider is a stellar example of something that violates the interface segregation principle. It seems like on its surface, the design of the ASP.NET membership provider is ideal. It provides everything that you would ever want to do with membership. Log in, log out, check password, change password, check if you're a member of a role, add you to a role, remove you from a role. All these things feel at first blush like all having to do with managing membership. But it turns out if you think about it, right, it's too fat. It's too much. If all you want to do is log somebody in and could care less what groups they're a member of, you could care less whether they can change their password, and don't have a password expiration policy, and so don't really want to check if it's expired either, right? Because of the way that thing is engineered, you have to implement every one of those methods. But we don't really, right? So what you do is you hand me an ASP.NET membership provider that you've implemented, some of which has methods I'm okay to call, and some of which have methods that blow up in my face when I invoke them with the not implemented exception, right? So you've basically just handed anyone who consumes your code a loaded hand grenade. Or more accurately, what you've really done is you've blindfolded them and led them into a minefield and said, here, some of these are okay to step on, some of them not so much, but I'm not going to tell you which, right? So I step on the first one and it throws a not implemented exception. You know what I do now? I go back and wrap every invocation of your method in a try-catch block because I can't trust a damn thing you wrote. I can't, right? Because you blew the contract. The contract is you hand me an object with a bunch of public methods. They're all supposed to be valid. The reason that unimplemented exception exists, right? And I work for Microsoft now, but I don't know this for a fact. But my theory as to why that exception exists is because there was probably a design guideline that when Visual Studio generates code for you, the result must be compilable. When you use the refactoring, it says, stub out this interface for me. And you get all those not implemented exceptions, right? My own read on why that was done was because when you've got a method with a return value, there are only two valid ways to make the compiler happy. Return a value of that type, or throw before you get to the return statement. And the decision was made, instead of return default of the type, the decision was made, throw an unimplemented exception. You were never supposed to leave those. They were never intended to be left in place. They're placeholder code. Unfortunately, they don't come with to-dos, write actual implementation, right? Which would be very, very helpful. At least you'd see that in your task list in Visual Studio, right? But the point is, when you leave those in place, you're basically walking consumers of your code through a minefield blind. But the reason you have to do that is because you are forcing me to depend upon interfaces I don't use. More accurately, you've been forced to depend on interfaces you don't want anybody to use, right? Because that thing violates the interface segregation principle. It's a great example. I love it because just about everybody has at one time in their lives interacted with that thing, right? And left exactly that minefield laying around in their code, right? What you do is you do a handshake thing, right? Talk to the downstream development team going, yeah, you know what? I'll only call the login method. None of the rest just ignore. Which, by the way, is partly what leads to legacy code, right? We're afraid to touch that membership login thing because every time somebody touches it, it blows up in our face, so let's just leave it alone, right? We'll write a shim that talks to the next database when the first database it was designed to talk to doesn't talk to it anymore, right? We'll do an ETL at midnight, which loads all the users into the database that it knows how to talk to because nobody wants to touch that membership provider. So let's look at this in practice. For this, we're going to need to switch to another solution, which, if I've done my job right, looks exactly like this solution with one slight modification. Okay, come on, get on there. Come on. Don't run away. There we go. Yes. Okay, fine. All right. So, this guy looks pretty much like our last solution in the sense that there's a tabloid report and a letter report, they both derive from report, and there's a report printer and a tabloid report printer, and they both derive from report printer and all the rest of that kind of thing. The part that's different here is that we've introduced an interface for data access. So our data access class, which we've not really even spent a whole lot of time talking about yet, right? All of our focus has been on formatting and printing and reports and all that. Now we're going to have some fun with the data access class. So our data access class, as you can see from this diagram over here, right, implements this interface iData access. Let's go look at that. Here is iData access. We've probably all designed interfaces very similar to this in our lives. Right? It's got a way to get data, it's got a way to perform a query, it can save some data, it can delete some data, and so on. And so, in the exact same way that we look at the ASP.NET membership provider and say, well, that's all stuff about membership, I'm sure it's fine all to be there. This is stuff all about data. I'm sure it's fine all to be there, right? Except it turns out in the context of our report application, we actually don't really care about all of these. Let's go to our implementation. Here is our data access class. I'm going to have to replace the batteries on my mouse because it keeps freaking out on me. Okay. Right, so we've got get data. And of course, because we don't care about the other methods, we've left an unimplemented exception in place. Here's your minefield. Anybody who gets a hold of the data access class has no idea which of these methods are safe to call and which of them will blow up in their face. We'd like to solve this problem. So we're going to solve this problem by refactoring our interface. And so what we're going to do is we're going to decompose this interface. interface decomposition, and I don't just mean interface, right? I mean public API, right? But interface decomposition is a very valuable tool in your OO tool chest, right? Don't leave it on the table and ignore it, because it can be extremely powerful. So let's do this. Let's introduce the extract interface refactoring. Now, it sort of seems counterintuitive to extract an interface from an interface, right? We're used to extracting an interface from a concrete type or even an abstract type or something. But it's just as legitimate to refactor, to extract an interface from another interface. And we're going to call this one I get report data. And what we get is this. So we get our new interface, I get report data, and it's got the method in it. And what the refactoring does, of course, is it changes the interface declaration to say IData access and then colon some other interface. The way we've been taught, right, to read that colon aloud, right, what we mean is implements, right, or derives from, right? What we really mean here is includes. IData access includes the iGetReport data interface. Right? So any class that says, I'm going to implement this, must do these, and that one. Right? So as we decompose the interface, we're also recomposing it. Primarily with the goal of ensuring backward compatibility. What if somebody actually had taken a dependency on iData access, as in fact was the case here? What if instead of not implemented, right, I really did need to implement that whole interface? I need to not break this code. So the original definition, all of the methods, all of the API that made up the original iData access interface, still make it up now, because we're recomposing them back together. Now, what this lets us do, of course, is go to data access, and what we'd like to do is comment these out, because these are terrible, right? This is just the worst programming practice on earth. Let's get rid of that. And of course, the compiler is very unhappy because we don't implement all the methods. So let's actually change this to be iGetReport data. Now, this is a good start. The compiler will be happy, and we can run the code. It should still work, 11by17.matrix. But we're not actually done yet. I would actually suggest that it's worthwhile to continue to decompose this data access interface. Not so much for the sake of this application, but for the sake of anybody else who wants to take a finer grained dependency on this. So let's do this. Let's extract another interface. This one, I query data. And we'll pull out the do query. And I'll even do another one. We're going to call this one I persist data. Okay. Now, what we're left with, interestingly, is a completely empty iData access interface. But what it says is actually more important. It says that implementing this interface means that I get report data, I can query data, and I persist data. This is a goofy way of naming interfaces. We have been taught that the way this works is object interface, right? I customer, customer. I order, order. I person, person. Stop thinking that way. Interfaces aren't things, they're behaviors. Stop thinking of them as nouns and start thinking of them as verbs. Because as soon as you do, and this is why, even though it's goofy, right? I mean, let's think of it like a sentence. I can send email, right? If you think of it that way, and I'm not saying you need to name them that way, but I'm saying if you think of it that way, and naming it that way helps me think of it that way, then interface composition becomes obvious to you. Because like behaviors group together, which is what you want. Because when you're consuming them, you're going to consume like behaviors as a unit, right? When I'm in a part of the system where I'm all about persisting data, I could care less whether I can query or get report information. All I care about is this. And so if I can take a dependency on just this lightweight part of the interface, I'm golden. because the rest of this can add 6 more things that won't break me. If somebody comes up with, under the original design for iData access, if someone says, you know what, there's one more method we need. Oh, screw it. Now I got to go back to every place I've implemented iData access and add that new method. Right? We're decomposing the responsibilities of this interface into like behaviors. Like behaviors are likely to be consumed together, so grouping them together doesn't carry a penalty. Saying everything and everything that has to do with data access just magically belongs together because it's all about data access is too coarse-grained a design. Right? It gets us into trouble. It has us start throwing out implemented exceptions just to keep the compiler happy. We don't want to design our software so that the compiler is happy. We want to design our software so our software developers are happy. Right? Probably our end users too, right? But the point is, right, just satisfying the compiler is not enough. And so by thinking about your interfaces as verbs, not nouns, it encourages you to think like behaviors together. Always provide the composed interface. If someone wants the whole ball of wax, don't force them to do this on their declaration line. Right? As you decompose, you always want to provide the convenience aggregator. Maybe several of them. Maybe it turns out that in a lot of cases you often query and persist together. Come up with a name for that. And create a whole other interface that's just query and persistence together. And then someone can take a dependency on the fine-grained one, or the slightly more coarse-grained, or the absolute fat daddy at the top. Right? But be thinking about this as you're designing your interface hierarchies too. Right? Interfaces compose just like objects. This is the benefit of the interface segregation principle. Lastly, I know we're happy to hear me say that, right? The dependency inversion principle. So, no one obviously would like to plug in the lamp by soldering into the wall. And the commonly understood reason that we don't like to do that is because we say to ourselves, well, plugging into the wall would be a hell of a lot quicker, right? So it turns out what the dependency inversion principle is actually talking about is not just the ease with which you can plug it in, but the ease with which you can unplug it. Once you've soldered the lamp to the wall, if you want to move it from that corner of the room to that corner of the room, it's a whole lot harder because you chose to solder it. Right? It's not just about the ease of plugging it in. It's about the ease of unplugging it as well. And more importantly, of course, replugging it in somewhere else you happen to need light. Right? This is really at the core of what's intended by the dependency inversion principle. It's not just about ease of composition, it's about ease of unplugging as well. The dependency inversion principle. High-level modules should not depend upon low-level modules, both should depend upon abstractions. And abstractions should not depend upon details, details should depend upon abstractions. This is another one of those fortune cookie-like slides. And you look at this and you say, yeah, and my magic numbers are 16, 14, 12, and 11, and this is the Chinese word for, I don't know what software engineering means, right? But if we decompose these, they actually do mean something useful. Let's tear it apart. High-level modules should not depend upon low-level modules. Both should depend upon abstractions. What this really means is that when you have two things that need to relate to each other, the common glue that they should share should be an abstraction. Right? It doesn't mean an abstract class, right, per se. There are lots of different meanings for the term abstraction, lots of different manifestations for abstractions in our code, right? But when two different modules, high or low, right, need to talk to each other, the common shared secret that they both understand that allows them to interrelate and interoperate should be an abstraction. And that abstraction should not depend upon details, but details should depend upon abstractions. Right? This suggests, think back to our tabulated report formatter, right? Our tabulated report formatter was a detail. It knew 11 by 17, it knew all 11 by 17 margins and all the rest of that, right? What's the abstraction it depended on? Well, we had just the report formatter abstraction, right? So the dependency is not from highly detailed and specialized to general. the dependency is from general to more specialized. If we look at this in code, we'll actually see how some of this actually works. So, let's start at the top. Yes, I know this is not the optimal resolution. Report equals new tablet report. Great start. Let's look inside our tablet report. We have a problem. Tablet report certainly depends on the abstraction, that's good. It depends on report, that part works. But it turns out, if we think about this for a minute, tabloid report is actually doing a hell of a lot. It's not just a tabloid report. It's a tabloid report that prints to a dot matrix, right? It makes a whole lot of choices for us. So what do we do if we have a tabloid report that needs to print to a different printer? Oops. Well, this won't work, because right here, the tabloid report is deciding for itself what printer it should use. We would rather not have that happen. We would rather not have the report decide what printer to go to. It feels really peculiar to me. Feel odd to anybody else? Why should a report decide what printer to print itself to? Seems like not the right place for that choice. So let's refactor this a little bit to do the following. We're going to add a field of type data access. And then what we'd like to do is get rid of that line. Because that's the line that causes us the problem. That's the line where this guy decides how to get data. Our tabloid report knows how to talk to the database. That feels really odd to me. What if we suddenly want to get data from an XML file? Well, this won't work, right? So we don't want that decision to be made here. Report formatter, same problem. Let's create a field, primarily so that we can comment out this line. And then lastly, let's do this. Again, so we can do that. Now, having done this refactoring, and in the absence of any tests, I must run the code. Oh, thank goodness, finally a failing test. This is the red part of red-green refactor, right? So, NRE, right, null reference exception. Why? Well, because I tried to invoke a method on data access, but now that it's not deciding, nothing is deciding. Right? And so in the absence of anything deciding what we should do for data access, it's just saying, yeah, all right, fine, I'll just call the method you told me to, what the heck, right? So let's fix this problem. We're going to fix this problem by telling the report which of these dependencies to use. And we're going to do that, by initializing the field from a constructor parameter, like so. What this refactoring does is it basically just adds an argument to the constructor and initializes the field in the constructor method body. We're going to do the same thing here and the same thing here. I'm going to hit return here so that this all appears on the same line and we can see it all, right? So tabloid report is now an object that requires in its constructor a data access instance, a report formatter instance, and a report printer instance. If we try to compile this, it won't work. Because, right, we don't actually have a constructor that takes 0 arguments. So where is that happening? Oh, right here, of course, right? We're trying to new up a tabloid report without satisfying the constructor dependencies. So let's satisfy them. New data access, new tabloid report formatter, new tabloid report printer. And I'm going to hit return here again so we can see it all, right? So when I new up the tabloid report, I'm telling it I want you to use this data access instance, this report formatter instance, and this printer instance. And let's run it. And it's happy again, 11 by 17 dot matrix, right? Now, let's imagine that we wanted to actually send a letter report. Actually, what let's do is, let's perform the same refactoring on letter report. I'm going to make that with the goal of, with the goal of commenting that out. Oops. I'm going to make that. So we can comment that out. And we're going to do this here too. Oops, sorry. Not what I had in mind. Sorry, let's do that again. Report formatter. And then lastly, report printer. Then let's solve this problem. Oops, got to comment these guys out, sorry. Comment that out, comment that out. Then we need to initialize these guys in the constructor again, so let's do so. Initialize in constructor, initialize in constructor, initialize in constructor, and we see it. So now if we want to actually use our letter report printer, right, what we can do is comment these guys out. Say new, actually it could just be a new letter report. And we'll have to give it data access, and a letter report formatter, and a letter report printer. And we'll certainly add a variable just called report so that it works. Sorry, wrong name. Report, like that. Okay, we'll just hit enter there so it all shows up on the page. And this is okay to just be that. And let's run that guy, and we should get an F/11 and laser printer, right? Now, an interesting thing starts to become evident to us, though. And it was beginning to become evident to us when we were editing this line up above. So I'm going to comment this out. I'm going to comment this back in. And for those of you who were astutely watching as I typed, right, what you probably saw as I began to fill in the constructor parameters is that unlike the letter report, I had a couple of choices for tabulate report. So new data access, new notice, right? I get both letter report formatter and tabulate report formatter. Why is that? Well, it's because, and I'll finish it out here, new tabulate report. It's because if we look in the tabulate report declaration, what we see is that these guys are the abstract type. Report formatter, report printer. Why did I only get one choice when I did the letter report? Well, that's because if we look here, we've used the explicit derived types, letter report formatter, letter report printer. Watch what happens if we change this slightly. There's actually a refactoring, so common it's here, called use base type where possible. And of course there are two base types of letter report formatter. One is system.object, not a great refactoring. The other one, however, is of course our report formatter. So by all means, let's do that. And we'll notice that it changes the type here, and it also changes the type in the constructor argument. We're going to perform exactly the same refactoring here. Use base type where possible, and again, pick the report printer as our base type. And there we go, right? Now, what we realize here is that as soon as we do that, both the tabulate report and the letter report can have any formatter and any printer. So if we have two different reports that we tell how to get data, and we tell how to format, and we tell where to print, why do we need two reports? Right? Why do we need two reports? It turns out we don't. Right? There's really no benefit to having both a tabulate report and a letter report. I'll prove it to you. Look at letter report, and if we refactor away these unused directives, and look at tabulate report, notice that as I toggle back and forth between them, the only thing that changes is the name of the class and the name of the constructor. They are identical pieces of code. They don't know where to get data from. They don't know how to format, and they don't know where to print. But they do know how to get data, format something, and print it. Right? So what we've actually done is we've come full circle on the original introduction of multiple formats for reports. Right? It's now actually possible to take all of this, like so, and go to the report class, and not make it abstract anymore, and paste that in there. Of course, the constructor's now named the wrong thing. And do that. And now, of course, in order to make the compiler happy, we do need to take our letter report and comment entirely out, and our tabulate report and comment entirely out, because its inheritance hierarchy is totally broken. this type no longer exists, but what we are now left with is a report which we can print to 11 by 17. Oh, whoops.
Override somewhere.
Yes, you're quite right. Thank you. Yeah, my pasted code. Yeah, that's why you should never copy and paste code. So, 11 by 17 to the dot matrix. If we go back to our program and change this to be the letter report formatter and the letter report printer, like so, can also print to the 8.5 by 11 laser print, right? So it turns out that what began as one concept and needed to evolve to multiple concepts with much more specificity, is now possible to actually roll up into a single concept, this concept of a report that knows when to get data and when to format it and when to print it, but not how, right? Its dependencies have been inverted. Instead of it knowing how to get data, and it knowing how to format, and it knowing where to print, those dependencies are sent down to it, right? In this particular case, they are injected through the constructor arguments. There are many different techniques for doing this, right? This is just one of them. But this is sort of the core benefit of the dependency inversion principle, right? As soon as objects stop making these decisions for themselves, it becomes possible for you to direct them. Imagine a menu here in our console app that says, what size report would you like? Where would you like it printed? And then in response to that, combines these arguments appropriately and constructs the right report instance and calls print on it, right? Oh, by the way, where would you like to get data, right? From an XML file, from a CSV file, from a database, whatever it might be, right? Answer the question, what data do you want? What size do you want it? Where do you want it printed? I will do that for you because I am a report. I know how to do these things. I don't know the specifics, and I don't really care to know the specifics, but I know how to do these things. I'm good at this. Just give me the tools. Give me data access, give me a way to format, give me a printer to print to. I'm good with that. I can take it from here, right? And that's what we're doing. So, we've come a long way from a single class with a single public print method, right? Largely through decomposition. Doesn't seem like you could actually take a class with two private methods and one public method and decompose it into quite as many pieces parts as we actually decomposed it into. And this was a simple piece of software. Like, you couldn't get any simpler than this, right? But this is what we did, right? We tore it all apart. Now, two kinds of reactions people have when they look at this photo. Some of us react with, wow, the possibilities of what I could build by putting that together. And some of us look at that and go, oh my God, do I sort by color? Do I sort by shape? I don't even know how many of these I have. What if I get started and I don't have enough of the blue squares to finish? Oh my God. And the truth is that we all have both those reactions, right? To varying degrees. And the way we react to this photo as software engineers sort of talks a little bit about our philosophy, right? Do we think about opportunities? Do we think about complexity? Do we think about recomposition as an opportunity, or do we think of it as an onerous burden? The goal, right, is to take this. Once we've decomposed everything into its pieces parts, right, the goal is to turn that into this. Here's a working system, built out of, quite frankly, a lot more than those parts we just looked at a moment ago, right? But the point is, once it's decomposed to that level, right, recomposition into this or something entirely different becomes much more feasible, right? Because we build that flexibility into our software. So our ability to respond with that pile of blocks to management saying, can you build me a city, versus management saying, can you build me a castle, or anything else, right, increases because we've designed with that level of flexibility in mind, right? Not by externalizing everything in 3,000 config files, right? Just by thinking about the way we design our software in order to be flexible enough to respond to the need to change. And the goal is, of course, to turn that pile of blocks into something like this with minimal effort, right? Because I think we can all agree, right, that One class with 10,000 lines of code in it is no good. But we can also agree that 10,000 classes with one line of code in a piece is also no good. Right? Bad in whole different ways, but still bad. So the point is, right, that when we decompose things, there is an inherent acceptance that we will be increasing the overhead of reassembly. This is the problem that dependency injection frameworks attempt to solve for us. Right? So for those of you who've asked, what is a dependency injection framework? Think of it like a really smart factory that knows how to build objects for you. Right? In the .NET space, there are lots of these. Right? There are things like structure maps, Spring.NET, Kessel-Windsor, NInject, Thumb, Unity. Lots more of these things. Right? This is both a solved problem and also a problem solved in many ways. Right? There are pros and cons to all of these, and this isn't even all of them. Right? And this is just in the .NET space. Right? There are plenty in the Java space. There are plenty in other spaces too. Right? Hell, there are even JavaScript dependency injection frameworks. Right? So don't look at this and say, I'm not in a statically typed language. None of this stuff is for me. Right? The truth is, it is. Right? Because whether you're doing, statically typed objects and things like .NET and Java, you're doing prototypely typed objects as in JavaScript, right, or other dynamic languages, it's the principles that we're talking about here that are applicable, right? Not the implementation details. The implementation details here are very platform and language specific, but the concepts are equally applicable elsewhere, right? The implementation will vary highly. So quick closing thoughts as we wrap. We have to have at least one more principle. This is the PPP, right? Peter Parker principle. Do I expect you guys to all go back to your code bases tomorrow morning and begin refactoring them into little bits and pieces just like I just did? No. Not in a million years. Right? It's not going to happen, and I don't even want it to happen. It would be a terrible choice for any of you to decide to go back and do that. What I would suggest you do, though, is think carefully about the techniques that you've seen here, and think about where they can benefit you. Right? Every software endeavor that you undertake requires an ROI calculation. Fold some of what you've seen tonight into your ROI calculation. Decide, is it worth investing in improving the design here for future flexibility? Right? Is it worth paying the penalty of decomposition here in order to increase our flexibility of recomposition here? Right? Ask yourself those questions. Early on in the slide deck, we talked about the boiling a frog problem. Right? Good code doesn't go bad overnight. Any Boy Scouts in the room? A couple, right? Boy Scout principle, right? You walk into the forest, always leave it better than you found it. Right? The idea is, I walk into the forest, I'm eating a candy bar. I drop the candy bar wrapper on the ground. When I bend down to pick up the candy bar wrapper, while I'm down there, in addition to picking up the candy bar wrapper, maybe I should clear a little bit of the kindling away from the forest floor. So the next fire that we have here doesn't burn quite as bright, doesn't cause quite as much damage, right? I'm leaving the forest a little better than I found it. Because honestly, I don't have the spare time to go into the forest and clean the whole forest. I just can't, right? It's too big a job, right? But I can do my little bit. While I'm in the forest, I can make sure that when I leave, it's a little better than I found it. This is how you undo the boiling a frog problem. Good code doesn't go bad overnight, but your bad code isn't going to get good overnight either. Just like it got bad slowly, it's going to get good slowly. And for exactly the same reason. Because it got bad as you got a little less disciplined and a little more corner cutting and a little less focused on ROI. It's going to get better the exact same way, but in reverse. Because you're going to be a little more disciplined, a little more forward thinking, a little more investment minded. That's how it's going to happen. Don't go back and refactor your code base like I just showed you. Go back and do that. While you're in there fixing bug number 165B, look around the surrounding code for bug 165B, or more importantly, look at all the code that made it hard for you to find and correct 169B. Refactor that. So that the next person who's got to go in and fix a bug in the same place doesn't have the same hardship of isolating it. Right? Think about the person who's going to come after you. Make the path a little bit easier for them, just a little, just a tiny little bit. And over time, your code base will improve. I promise you. I've seen it happen. So there were a lot of slides I could have chosen for this one, but I particularly like this one for a couple of reasons, right? The first one is that it clearly shows somebody who was in a damn hurry to get home and clock off the job, right? No doubt about that, right? But I could have found a lot of slides that were about people cutting corners to get home and clock out. The beauty of this slide is that somebody cut a corner so that they could get home and get off the job as soon as possible and go out and have a beer, but they did it in a way where somebody, frankly probably not them, is going to have to come back after the fact to clean that up. Someone's going to have to not only scoop up that possum or whatever in God's name it is, but someone else is going to have to come back with the paint truck. Because as soon as you remove the possum, what do you got? You got gaps in the line. Right? So not only was a corner cut here, but a corner was cut here in such a way that there's more work for who follows you. Right? I'm not arguing for no cutting corners. Right? Cutting corners is just someone else's look at someone else's valid ROI calculation. Okay? What looks like cutting corners to one person is an efficient application of effort to someone else. That's just life, right? Corner cutting is what people who get slighted call it. Efficient business decision is what people who get the accolades call it. But it's the same thing. But don't do this, right? This is corner cutting with, I don't care the consequences. I'm just getting out of here. And the reason, of course, right, is that there is more to doing the job than just getting done. And lastly, before my voice completely dies, context matters. Do these things where they make sense. Do not do them where they do not make sense. Right? Use your intelligence, use your foresight, use your experience, apply these techniques where they're beneficial, and don't where they aren't. But that's the whole point. And that's the end. Thank you very much. So if there are any questions that did not get a chance to be asked during the talk, I'll field them now. Anyone? Yes?
With the Liskov one, the Liskov example, so all we did was rename the type, the report to a letter report, but nothing really changed the behavior of the code or anything really, the behavior, like the byte level or whatever you want to say, computer level. So was there really a violation of the Liskov principle, or was there more like a conflict between?
So in the code sample, right? This is another one of those places, frankly, where the code sample is too simplistic to demonstrate the actual pitfall, right? So the reason for the renaming and the reason that the renaming points out a potential violation is that we are using one specific type in place of another specific type, right? So for example, let's go back to the two ducks as an example, right? So I might have some code that cares which duck I get and some code that doesn't. So if all the argument to my method is duck, then I'm projecting to the outside world that I don't care which duck you give me, right? I don't care if you give me the live duck or the battery duck or some duck, some wind-up duck I don't even know about yet, right? As long as it derives from duck, I'm very happy. And if that's what I'm saying in my method signature, then that's what I need. That's the contract I need to hold to, right? That's the part of Liskov that is without knowing it, right? So without knowing that I'm getting a different type. So what I'm saying is, you can pass me any old duck. I might have another method that only takes a wind-up duck, because I do care in that particular method's logic that I'm only operating on wind-up ducks, and another one that only operates on battery ducks, and so on, right? But the point is that you have a choice. So part of this comes from the need. A lot of this only makes sense if you have relatively rich object hierarchies, right? A lot of people in their software have, just 1,000 types, none of which have any sort of relation to each other, right? So there's no polymorphism going on. It's just class 1, class 2, class 3. Hopefully they're not named that, but they don't have any relationship to each other, right? The benefit of polymorphism isn't just that I can substitute. It's that I, as the author of the method, with the signature line that I'm declaring, get to tell the outside world at what point in that hierarchy am I saying above this is okay and below this is not, right? Or vice versa. So if I have a method that just is going to call quack on a duck, right, then it's probably fine for you to just pass me the duck object, regardless of which derived specialized duck I get. If I have a duck where what I'm going to check is, how long will the duck live, right? The answer to that's going to be very different for the battery duck versus the wind-up duck versus the live duck, and the way I calculate it may be different, right? Because now I'm going to say, maybe I want to call age on the live duck, and I want to call battery level indicator value on the battery duck, and wind-up torsion and spring on the spring, wound-up duck or something, right? So what I need to do as an author of those methods is I need to be as specific or as general as I want to be. I'll give you a perfect example, right? One of the things that started this whole refactoring exercise was the problem we had of sending 11 by 17 prints to the laser printer, right? And that was part of why we introduced tabloid reports, so the tabloid report could only print to the dot matrix. But in our final solution, what did we do? We actually were so general about the report formatter and the printer that could be passed into the report that now it's possible to do what we were trying to prevent ourselves from doing in the beginning, which is pass in the laser printer and the 11 by 17 formatter. It's now possible to, again, fill our print queue with a bunch of unprintable documents, right? That's because that particular constructor signature, right, allows you to mix and match beyond the control of me as the class designer. That's a problem, right? What we need to do in this design, right, in order to get back to solving that problem is where we have specific combinations where I'm saying, no. Here, I can only take a tabloid formatter and the dot matrix printer. Then let's say that. Let's not say report formatter and report printer. Let's say tabloid report formatter, tabloid report printer. Because there's a method where I do care exactly what types I've got, right? Versus other methods where I might not give a damn. So let's just take the report formatter and the report printer and not be more specific about their types, right? That or any subclass is fine, right? So as the author of the method, what I'm saying in the signature line is, I need to broadcast to you whether I care or not about whether you're giving me the real type I'm asking for or a subtype. And I need to close my method, the entry point for my method, down to a narrow enough point where you looking at my method signature tells you what's okay, right? Tells you what I accept, right? That's my public contract with you. I can't, in my method, go, okay, well, if you really met the contract, then I'm going to branch left. But if you kind of met the contract, but it's a subtype where you did something really wacky with it, then I'm going to branch right? There's no way for me to know that without cracking open your code, right, and reading through it. And that's not really, quote, fair, right? You shouldn't require me to look at your source code in order to understand how to interact with your object, right? And that's really what the point is, right? Be as liberal or as constrained with your method signatures as you mean to be, right? Is really what it comes down to. Because that's your opportunity to broadcast the contract to the consumer of that object. Does that make sense?
Yeah.
But I agree with you. In the case of that specific example, there's not really enough there to evidence exactly that problem. And for what it's worth, that's a comment I've gotten on this talk several times, and I've tried several times to make it more complicated to get over that point, and it just ends up with a mess. I mean, because again, it's that balance between enough code to demonstrate the point and get the principle across. But it definitely requires a little bit more imagination than I would prefer, right? The problem is that more code becomes more questions about more lines of code that aren't really relevant to the problem, right? But to be honest with you, if you have suggestions for how I could introduce enough of that problem without it getting overly complicated, I would absolutely be willing to accept that suggestion, because I frankly struggle with it. Anybody else? Okay, well, thank you very much for coming out.
Thank you.